Hello students, welcome to science class. Today we are going to start chapter 16 light. Following topics we are going to cover in this chapter. First we will see introduction part. Then other topics are laws of reflection, types of reflection, image formation by a plane mirror, multiple reflection, dispersion and human eye. What is light? It is a natural agent that stimulates sight and makes things visible. Light is reflected from all surfaces. Light is a form of energy. What is luminous object and what is non-luminous objects? Objects that give out light on their own are called luminous objects, and objects do not give out light on their own are called non-luminous objects. And objects are visible due to reflection of light. Means when light falls on the objects, then objects reflects the light, and this reflected light enters into the human eyes and objects becomes visible to us. Okay students, let us understand it with the help of an example. In daytime, things are visible due to the sunlight. When sunlight falls on the object, then objects reflect this light, and this reflected light falls on human eyes, then things are visible around us. Okay students. So dear students, let us learn more about the light from chapter. Students, you know that light is a form of energy and it is required to see things around us because we generally detect the light with our eyes. We know that sense of sight is one of the most important senses through which we can see trees, plants, rivers, mountains, peoples and so many things around us. Here the question arises that how is seeing made possible and what makes things visible? We can say that eyes see the things, but we cannot see the things in the dark room. It means that eyes alone cannot see the objects. We need a source of light to make the objects visible. Okay students? Means it is only possible when the light coming from an object enter our eyes through which we can see the objects. Okay? Therefore, it is the light which makes the things visible to us. Now let us move to the next topic, laws of reflection. First let us know what is reflection. When a ray of light fall on the surface of an object, then object sends the light back. So the process of sending back the ray of light which falls on the surface of an object is called reflection of light. Students, you have done this activity in the previous class. When ray of light falls on the mirror, then mirror changes the direction of light. Mirror is a polished surface and it reflects most of the light that falls on them. Okay? Means the objects having polished shiny surfaces reflects more light than the objects having unpolished dull surfaces. Okay? Like a shining mirror. This shining mirror reflects back almost all the light that falls on it. Okay? And some important terms you should know. What is incident ray and what is reflected ray? Let us understand it with the help of activity 16.1. Students, in this activity, you have to spread a white sheet of paper on the table and take one plain mirror and comb. Now cover all the opening of the comb except one opening. Okay? Now through this opening, you have to apply torch light. Then you'll observe that when torch light falls on the mirror, after striking, it returns back in the same medium. The ray which falls on the mirror, that is known as incident ray, and after striking, it returns. This ray is known as reflected ray, and this phenomenon is known as reflection of light. Okay students, now you have to draw lines showing the position of plane mirror, incident ray, reflected ray. According to the figure 16.2, here it is the plane mirror. Okay, it is the reflecting surface of plane mirror. Okay students, now it is the incident ray, it is the reflected ray. Now you have to draw one perpendicular line that is known as normal. What is normal? Normal is a line perpendicular to the surface of the mirror at the point of incidence. Here it is the point of incidence, means where incident rays strike on the surface of the mirror. That point is known as point of incidence. Okay. Now let us move to the next figure, that is 16.3. Here it is the incident ray, reflected ray, and it is normal. And the angle between the incident ray and normal is known as angle of incidence. Okay. And the angle between the normal and reflected ray is known as angle of reflection. Now you have to measure the angle of incidence and angle of reflection. Then you will find that they are equal. Means if angle of incidence is 40, then angle of reflection will be 40. If angle of incidence is 30, then angle of reflection will be 30. Okay, students? Means angle of incidence is always equal to angle of reflection. So it is the one of the laws of reflection. That is, angle of incidence is always equal to the angle of reflection. Now, let us move to the next activity. According to this activity, when the whole sheet of the paper is spread on the table, then it shows that the incident ray, reflected ray and normal, okay, and all lie in the same plane. But when you bend the paper, in that case, we can create a plane different from the plane in which the incident ray and normal we can see, but we do not see the reflected ray. Okay, students? So, this activity indicates that incident ray, normal at the point of incidence, and reflected ray all lie in the same plane. So students, it is the another law of reflection. What is the another law of reflection? The incident ray, reflected ray and the normal to the reflecting surface lie in the same plane. Okay. Now, let us move to the next topic, image formation by plane mirror. Students, in standard 7, you have studied about it. What is the nature of image formed by the plane mirror? That is erect. Okay, and it is the same size of the object. An image formed behind the mirror and it could not be obtained on the screen. Okay, so the image formed by the plane mirror is erect, same size of the object, and behind the mirror object and image distance is same, and it is virtual image because it cannot be obtained on the screen. So let us understand little more about the formation of an image by a plane mirror with the help of activity 16.3. Let us understand it with the help of figure 16.5. Here PQ is the plane mirror. Let us understand it. Okay, and it is the reflecting surface of the plane mirror. O is the source of light. Then OA and OC is the incident ray. Okay, when both incident rays strike on the surface of the plane mirror, then it reflected. Then here AB and CD is the reflected ray. Okay, students. And it is the normal for incident ray OA and it is the normal for incident ray OC. Okay. Now, you have to extend this both reflected ray. You will observe that they will not meet. Okay, students. Now, you have to extend them backward of the mirror. Okay. Now, you will observe that they will meet at point I. Okay. So, for viewer eyes E, the reflected rays appears to come from the point I. Okay. Actually, the reflected ray do not meet at I, but it appears to meet. So, we can say that a virtual image of the point O is formed at I. Okay. And such type of image is called virtual image and it cannot be obtained on the screen. Means in case of the plane mirror, two reflected rays do not meet in front of the mirror. it appears to meet behind the mirror. So such type of image is called virtual image. Okay, students. But in standard 7th, you have studied about the image formation by the concave mirror. In case of the concave mirror, two reflected ray meet in front of the mirror. So such type of the image is called real image, and real image can be obtained on the screen. So the image formed by the plane mirror is virtual because two reflected rays do not meet in front of the mirror. They appears to meet behind the mirror. So such type of image is called virtual image. Now let us know about the lateral inversion. What is lateral inversion? The image formed by a plane mirror is laterally inverted. Means right side of the object appears left side. Okay, and left side of the object appears right side. This is known as lateral inversion. Now let us move to the next topic, that is regular and diffused reflection. What is regular reflection? Let us understand it with the help of figure 16.8. When a parallel beam of light falls on a polished surface, it reflected back in one direction. You can see here. Okay, such type of reflection is known as regular reflection. Now what is diffused reflection? Let us understand it with the help of figure 16.6 and 16.7. When a parallel beam of light falls on a rough surface, then it reflected back in many directions. Okay, students, so such type of reflection is known as irregular reflection or diffused reflection. Means irregular reflection takes place through the rough surface and regular reflection takes place through the polished surface. Okay, and images are formed by regular reflection. Now let us move to the next topic. Reflected light can be reflected again. Let us understand it. When the ray of light reflected by a plane mirror are incident on another plane mirror, the reflected rays are reflected again. In this case, the reflected rays of the first plane mirror becomes incident ray for the second plane mirror. Let us understand it. It is the first one plane mirror, okay, and this one is the second one plane mirror. Okay, students, when ray of light falls on the first one plane mirror, then it will reflect, okay, and it will fall on the second one mirror. Again, this ray of light will reflect. So for the first one mirror, this is the incident ray and it is the reflected ray. But for the second one plane mirror, this reflected ray will be incident ray, and again this reflected ray will reflect. So reflected light can be reflected again. Okay. Periscope makes use of the two plane mirrors. What is periscope? An optical instrument in which reflected light is reflected again is called periscope. Okay, and periscope is a long tubular device through which a person can see objects which are out of the direct vision. Okay, and periscopes are used in submarines, tanks, and also by soldiers in bunkers to see things outside. Now let us move to the next topic, multiple image. We know that plane mirrors forms a single image of an object. But what happens if two plane mirrors are used in combination? Let us see in activity 16.5. Students, in activity 16.5, we observe that when two plane mirrors are kept at right angles to each other, their number of images will be 3. Okay. And when two plane mirrors are kept parallel to each other, means at 0 degree, then number of images will be infinite. Similarly, find out the number of images when the two mirrors are kept at 45 degree, 60 degree, 160 degree, 180 degree, etc. Okay. Students, now let us know about Kalyodoscope. So this idea of the images formed by mirror placed at an angle to one another is used in Kalyodoscope. to make numerous beautiful patterns. In activity 6.6, you have to make a Kalyodoscope by yourself. It is so interesting activity, students. Process is given here. So what is the uses of Kalyodoscope? Kalyodoscope is used to see a variety of patterns in the tube. And an interesting feature of Kalyodoscope is that we will never see the same pattern again. Okay, designers of wallpapers and fabrics use Kalyodoscope to get ideas for new pattern. Now let us move to the next topic, sunlight, white or colored. Students, the sunlight is referred as white light because sunlight consists of 7 colors. And in class 7th, you have studied that when sunlight passes through the prism, then it splits into 7 colors, and this phenomenon is known as dispersion of light. Okay. Now, let us see activity 16.7. To understand that sunlight consists of 7 colors, let us see this figure. According to this activity, you have to take a plain mirror. Okay. After that, put this plain mirror in a bowl. Okay. Now, fill the bowl with water and gently put this arrangement near a window in such a way that the direct sunlight falls on the mirror. Now, adjust the position of the bowl so that the reflected light from the mirror falls on the wall. Okay. So, reflected light will be seen to have many colors. It is due to the reason that the mirrors and the water forms a prism and breaks up the sunlight into 7 colors. So, this activity proved that white light consists of 7 colors. Okay, and splitting of white light into its color is known as dispersion of light. Rainbow is a natural phenomenon showing dispersion. Now let us move to the next topic. What is inside our eyes? Students, eye is one of our most important sense organ which gives us the sense of vision. Okay, we see objects only when light coming from objects enters our eyes. So it is important to understand the structure and working of the eye. So let us understand the structure of the human eye. The eye has roughly spherical shape. Outer coat of the eye is white. It is tough so that it can protect the interior of the eyes. Okay. Its transparent front part is called cornea. Now behind the cornea, we find a dark muscular structure that is known as iris. Okay, in the iris, there is a small opening called pupil. Okay, and size of the pupil is controlled by iris. Okay, and iris is the colored part of the eyes. Some person has green eyes, some person has brown eyes due to iris colors. Now let us understand the structure of human eye with the help of figure 16.14. Cornea. Cornea is the front bulging part of the eyes. Okay. Iris. Iris is the colored part of the eyes and located behind the cornea. Okay. And lens. It is the lens, and lens lies behind the pupil and iris. Okay. Retina. Retina is the acts as a screen of human eyes, means image will form on retina, and retina made up of 2 types of cell, that is known as rod cell and cone cells. Okay students, now ciliary muscles. What is the function of ciliary muscles? Ciliary muscles hold the lens in position, you can see here. Okay, now optic nerve. What is optic nerve? It is a bundle of nerves bringing from the brain and entering the eyeball from behind, and it carries visual message to the brain from retina. Okay, so these are the structure of human eyes. Now let us move to next paragraph. Behind the pupil of the eyes, a lens which is thicker in center. Students, what type of lens it is? It is a type of convex lens, because convex lens is thicker in middle and thinner at the both edges. Okay, so such type of lens is known as convex lens. And the lens focuses light to form an image on retina. Okay, Retina acts as a screen for image formation, and retina made up of several types of nerve cells. So sensation felt by nerve cell, then it is transmitted to the brain through the optic nerve. Retina made up of two types of cells, that is cone cells and rod cells. Cone cells are sensitive to bright light and rod cells are sensitive to dim light. Now what is blind spot? At the junction of the optic nerve and retina, there are no sensory cells, so no vision is possible at that spot, and this is called blind spots. Okay, now let us move to the next important topic, persistence of vision. What is persistence of vision? The impression of an image does not vanish immediately from the retina. It persists there for about 1/16th of a second. So if still images of a moving object are flashed on the eye at a rate faster than 16 per second, then the eye perceives this object as a moving. Means even after object is removed in front of the eye, its images retained on retina for about 1/16th of a second, and this is called persistence of vision. Okay. So persistence of vision is the ability of an eye to continue to see an object for a very short period of time, even after the object is removed. Okay. So due to the persistence of vision, we are able to see movies pictures in a cinema hall. Okay, students, because the movies that we see are actually a number of separate pictures in proper sequence. They are made to move across the eye usually at the rate of 20 pictures per second, faster than 16 per second. So under these conditions, the image of one picture seen on the screen persists on retina till the image of next picture falls on the screen, and so on. Okay, so we see a moving picture. Okay, students, now it is easy for a person with normal eyesight to see both nearby and far objects clearly. But what is the least distance of distinct vision? Means what is the near point of an eyes? The near point of an eyes is 25 centimeter. Means the least distance at which a normal eye can see an object clearly is called near point of the eyes. Okay, and 25 centimeter is the near point for a normal eyes. Now let us know about the defect of vision. Some person can see objects close to them clearly and cannot see distant object clearly. Means they can see nearby object clearly but they cannot see the far object. Such type of disease is known as myopia. Okay. On the other hand, some person cannot see objects nearby clearly but they can see distant object quite well. Such type of disease is known as hypermetropia. Okay. And with suitable corrective lenses, this defect of the eyes can be corrected. Means myopia is corrected by using spectacles containing concave lens. Okay, and hypermetropia is corrected by using spectacles containing convex lens. Now let us know about the cataract. What is cataract? Students, it is the defect of the eyes which usually occurs in the old age. In this defect, the lens of the eyes of a person becomes cloudy, okay, which result in blurred vision, and this condition is called cataract, which result in loss of vision. Okay, students, but this defect can be rectified by removing the old lens from the eye and inserting an artificial lens at that place. Okay, now let us move to the next topic, care of eyes. Students, we know that eyes are very important part of our body, so we must take good care of them. If there is any problem in your eyes, then you should consult with eyes specialist. Okay, if advised, then use suitable spectacles. Okay, and avoid reading in very dim or very bright light, and do not look at very bright or sunlight directly. Okay, Don't rub your eyes. If something falls in it, immediately wash your eyes with water and consult a doctor if the problem persists. Okay, and while reading, maintain a distance at least 25 centimeter between your eyes and the book. Okay, students. So these are some tips by which you can take care your eyes. And one important thing is here, you have to take balanced diet. Means it is very important to eat a balanced diet with sufficient quantity of vitamin A to keep your eyes healthy, like raw carrots, broccoli, green vegetables, cod liver oil, okay, eggs, milk, curd, cheese, butter, fruits. Okay, these are the rich sources of vitamin A. Okay, now let us move to the next topic, 16.9. Visually impaired persons can read and write. Students, visually challenged people are those whose vision is extremely poor or they are blind. They are unable to see because either of their cornea, eye lens, retina or optic nerve fail to perform its function properly. So these people make use of other senses like sense of touch or hearing or man-made aids to identify things. Okay. So these can be categorized into two types, optical aids and non-optical aids. Okay, non-optical aids includes visual aids, tactual aids, auditory aids, electronic aids, while optical aids includes bifocal lenses, contact lenses, tinted lenses, magnifiers and telescopic aids. Okay, now let us move to the next topic. What is Braille system? The most common non-optical aids used by visually challenged people is Braille. It is a tactual aids which is based on the sense of touch. The Braille system was first developed by Louis Braille. Okay. This system was adopted in 1932. The Braille code for common languages, mathematics and scientific notation. In Braille system, there are 63 dot patterns or characters, and each characters represent a letter, a combination of letters, a common word or a grammatical sign. Okay, and dots are arranged in cells of two vertical rows of 3 dots each. Okay, and one or more dots in a cell may be raised. You can see in figure 16.18. Okay, some symbols in Braille. So visually challenged person can feel this raised dot with their fingers and recognize the letters. This way they are also able to read books and other text printed in Braille. Okay, students, and Braille can be produced by hand or by using machines like typewriters or computers. Plain English text can be converted to Braille by using a special computer software. Special keyboards based on the Braille are available for blind now. Okay, students, now your chapter completed. These points are very important. You have to learn all these points. Okay, now your chapter completed. I hope all of you understood the chapter. Thank you.